Okay, so I made this flow chart for us to go through all the different reaction types as a review for those of you who are still struggling. We'll see if it helps. There's a blank copy of this available. There's also the typed out copy of it available, but I think seeing it develop is what's going to help most of you. So we'll find out. When you're trying to figure out what type of reaction you're writing, there are 4 key words that you want to look for first. So that first keyword that you'll that first keyword that you'll want to look for is burned. If it says that the reaction is that something is burned, we know that it's a combustion reaction. And therefore, we know that what we are doing is we are adding O2 and we are making CO2 and H2O. Again, this is going to be written out a lot nicer on the final copy. Just for me to do it live, this is kind of the best I can do because you all know my handwriting sucks. If we're talking about combustion, we're balancing C's, then H's, then O's is helpful. Why are we adding O2 and making CO2 and water? Think about burning a candle in the lab that you did. You know that as soon as you covered that candle up, you took away the oxygen from the air. So without oxygen, without this O2 here, sorry, I thought I was annotating. Without this O2 here, without the oxygen, nothing can burn. So that's how you remember that we're adding O2. Why does it always make carbon dioxide and water? If you know burning fossil fuels is bad for the environment because of the CO2 it releases, that will help you. Burning any hydrocarbon is combustion. We're going to make CO2. And then if you think about like the steam that might leave from things burning, you can think about water in that case. Okay, so look for the keyword burned. Another keyword you can look for is heated. If it's heated, we know we're dealing with a decomposition reaction, where all we're really doing in a decomposition reaction is breaking it apart. How you break it apart depends on what type of decomp. So what you want to ask yourself is it on the cheat sheet? Because you'll always have that cheat sheet. And if it is versus if it isn't, you'll do something different. So if it's on the cheat sheet, just use the cheat sheet. It literally tells you on that cheat sheet what to do. You don't have to have anything memorized. If it's not on the cheat sheet, because it's decomposition, we know that we are breaking apart. We're taking whatever it is, that's the left-hand side. We draw the arrow and then we break it apart. We break it apart into its pure elements. So if it's nitrogen oxygen, it would be into nitrogen plus oxygen. So we do have to worry about diatomics there, but there are no charges. We're not dealing with ions, we're dealing with pure elements, so no charges. That's the second keyword. Third keyword is dissolve. It'll often say dissolve in water, but honestly, the water is irrelevant. That's where we are still breaking it apart, but we're breaking it apart into ions. Therefore, there are no diatomics to worry about. Another note you might want to make for yourself is that water is not in the reaction, even though it's mentioned in the question, dissolved in water, for instance. And then the last keyword I tell you to look for is carbonate. So if it says carbonate, first ask yourself, is there also an acid in the problem? Like, does it also mention nitric acid or sulfuric acid or hydrochloric acid? If so, if yes, we're dealing with an acid carbonate. That's on your cheat sheet, so you just have to remember to follow it. If there's not also an acid mentioned, you want to ask yourself, does it say heated and you missed that keyword before, or decomposed? If it does say heated, you just didn't realize it earlier. Yes, it says heated. You're going to want to go back and look at, okay, well, what type of decomposition is it? If it does not say heated, then we're dealing with something with no keywords. So again, if you can remember these 4 keywords to look for them first, that helps you figure out a lot of the different reaction types. If it doesn't have a keyword, then we only really have 3 options. We either are dealing with 2 elements, sodium and oxygen, nitrogen and magnesium, whatever, 2 elements, or we're dealing with two compounds, or we're dealing with one of each, one element, one compound. If it's two elements, we're talking about synthesis. All we have are the two elements on the left-hand side, so our only option on the right-hand side is to squish them together. We crisscross them on the right-hand side. If we have two compounds, it's double displacement. That's the very first one you learned all year. That's where, you take whatever you have, and then on the right-hand side, you make sure everyone gets a new partner, making sure positives and negatives are still together. If it's an element and a compound, then we have single displacement. Again, on the right-hand side, make sure that if you can give anyone you can give a new partner to, give a new partner to, but again, a positive has to bond with a negative. So all those details I said out loud are typed in the final version. I'll link that for you. But yeah, I don't know. Let me know if that helps. Quick overview.